your page. I'm going to make sure I put up the correct answers. So what you'll notice is the correct answers are up there in green. So you can see how you did. And then if anything's less than 50%, I'm going to mark it to go over it. But if there's a question that is not less than 50%, you still want me to go over, do not hesitate to ask. So like this question, number 1, I feel pretty good because we have an 81% accuracy. Number 2, 75%. So again, it's pretty good. Answer is D. 3, fantastic, 94%. 4 is B. So 5 is one maybe I would look at. So we'll look at unit 2, number 5. 6 is C. 7, A. 8, so 8 is a definite. 9, 10 was A. It's okay, 9 was B. 11 is also B. 12 is C. 13, B. 14, E. 15, C. Sorry how difficult a lot of these questions are. Makes me a little anxious. 16 is C. 17. 18. 19. 20. So I have down 2, 8, and 17. Are there any other questions from that handout you wanted to see? Sure. like it wasn't like a knowledgeable rate. It was
Yes.
just like a, hey, that was a great guess rate. Got it. Okay. So let's go over those now before you get into your other packets. So we'll put, I'm pulling up those packets now. So number 2. Again, in number 2, your correct answer was D. Let's talk about why. So in number 2, we had a graph. We're told that the graph is twice differentiable and that this is the original curve. So then if the original curve is increasing and concave down, in my head, what I'm thinking about is, okay, what does that mean for the next curve? So if f is increasing, then f prime is positive. If f is concave down, then f prime is decreasing. And then f double prime is negative. So over to this side, those are the key pieces of information I'm sort of writing down for myself. So it says, okay, f of 1, well, f of 1 is 0. So even though the original is at 0, if the original is increasing, then this is going to be positive. So even though this is at 0, my graph is positive. So this is true. F prime of 1 would be greater than 0. However, the second derivative is negative. So the first derivative can't be positive and the second derivative to be negative. So same with here, this is 0, negative, positive, so that can't be true. And then in example C, this is positive, 0, negative, so not true. In D, it's negative, 0, positive. So answer D is correct. Do you see why answer D is now the correct answer? Does that kind of help to logically make sense how I wrote these over here on the side? Okay, the next big one we missed was number 8. Okay, so number 8 says the function y equals f of x is differentiable and decreasing. So again, the minute I see that f is decreasing, in my head I'm saying f prime is negative. It says on what interval is y equals f of x squared minus 2x decreasing? So what you would do is say, okay, f prime of x squared minus 4x times the derivative of the inside, which would be 2x minus 4. So we know that the derivative is negative always. So then to find the interval in which this part is decreasing, you would need to find the areas in which this part of the linear is positive. So we know that there's going to be, if you said 2x minus 4 equal to 0, then you get x equals 4. 4 divided by 2 is 2. So we get x equals 2. So then I know my breaking point is at 2. So automatically that eliminated for me answer choices that involved anything other than 2. So that automatically eliminated D and A. So I automatically eliminated D and A. So now you got a 50-50 with B and C. So remember I said you needed to know when the sign was what? So here's my 2. So if you plug in something bigger than 2 like 3 or plug in something smaller like 0, you get a negative. Here if you plug 3 in, you get 2 times 3, which is 6. 6 minus 4 would be positive. Remember that this is always going to be decreasing. So if I want to know when it's decreasing with this change, then I need this part to be positive. Because this is already negative. So negative times a negative would turn that to a positive, which would make it increasing. Or a negative times a positive would keep it negative. So the correct answer is C. Is everybody okay with that explanation? Okay, then we jump to 16. So 16 is a calculator allowed. It says if the derivative of f is given by, at which of the following values of x does f have a relative relative max? Oh, you tried to do it by hand. Okay. Exactly. So all you would do is put in that derivative on your calculator. Then you would look at your zeros. And if you're looking for a max, we're looking for the zeros to go from positive to negative so that you have an increase to decrease and gives you a max. So, yep. That's okay. That's the whole purpose of this, is to go through and be like, oh, there's my error. Okay, so 17 was also a calculator allowed, but what makes 17 a little bit trickier than the rest of them is your calculator is almost useless for 17, right? Like you're told that g of x is differentiable, and g of x, but this is the key ticket, g of x is always negative. This is my derivative. Which of the following is true? Well, this idea here that this is always negative, once again, you're taking into account what I kind of specified before. You want to know, okay, when is x squared minus 4 going to have a 0? So that's at negative 2 and 2. So what is happening at negative 2 and 2? Well, those are my zeros. What's happening between them? At 0, it's negative. At 3, it's positive. At negative 3, it's positive. So now, though, everything's getting multiplied by g of x, which is always negative. So this is a positive times a negative, making this negative. A negative times a negative is a positive, and a negative times a positive goes back to giving you a negative. So that g of x always being negative basically flips my quadratic and all my signs. So now this graph goes decrease, increase, decrease. So it says f has a relative max. Well, this is not representative of a max. So goodbye A. F has a relative min. Okay, I see a min. Okay, I see a max, so maybe I keep B. F has a min at -2 and 2. Well, that's a min, but that's a max. F has a relative max at both. No. E, it can be not determined. Well, no, I definitely determined that. So once again, I can see how or why my answer is justified to be. Any other ones on this first packet that you would like me to go over? Okay, packet number 2. Okay, question 1. So, sorry, I was looking through to see how we did. 1 is A, 2 is E, 3 is A, 4A, 5C, 6E, 7A or D. With these results, I expect all of you to get 5s. Yeah. And we're getting 94% correct. 8B, 9B, 10D, 11A, so 11's that first one, we're split 50-50. 12A, so sorry, 11 was A in case you missed that. 12A, 13C, 14A, 15D, 16A, 17D, 18D, 19A, 20 is B, 21A, 22D, 23A, 24 is B, and then 25, thank goodness we all know our AP exam is on Tuesday. Okay, so I wrote down 11, 16, 17, 21, 22, and 24. Any other questions you want to see? Yeah, which one? 13 and 20. Okay. So let's start with 11. It says f and g are twice differentiable and h is equal to f of g of x. What is h double prime? Okay, so I would start with my first derivative. So h prime of x is equal to the outside, so f prime, times derivative of the inside. So the first derivative is f prime g of x times g prime x. Your second derivative then is the first, so that's f prime g of x times derivative of the second plus the second times derivative of the first. So again, outside derivative first times derivative of the inside. So here what you'll notice is I have f prime g of x, I have g double prime x, and here I have g of prime x, g prime x, and f double prime x. So the only thing I notice is that these can become squared. So I see that for answer choice C. I also see that in answer choice A. And the difference between C and A is the product rule. And again, I know I should have a plus sign. So that gets me to A and B. And B doesn't have my squared. So my answer is A. Okay, 13, no calculator. What is the approximation for f of 0.5? So this is linear approximation, aka finding the slope of the tangent line. So first things first, find my derivative. So that gives me 1/2 e to the x plus 3 to the negative 1/2 times e to the x. So written out, that's kind of like 1/2 square roots of all of that with that e to the x on top. So that represents my slope. I need to find my slope at f prime of 0.5. So what I'm going to do is plug in 0.5 to that. So that gives me e to the 1/2 over 2 times e to the 1/2 plus 3 in my square root. And then I need to plug in and find my equation of a line. So linear approximation, or L of .5 is equal to plugging in 0.5 to your original. I'm actually going to, I will do your 13. I'm going to write it down because it's really hard to keep typing it. So bear with me. I'm just going to write it down on like a piece of paper in a second. Because I'm like having trouble typing it and I think it's hard to see typed. So we will still do 13. I'm going to write it down on my notebook. Get my document camera up. Jumping to 16. So 16 was A. I don't know what our most frequently answered one was, But again, we have a differentiable function. We have f of 3, f of 6, f prime 3, and f prime 6. And it says, what is the value of g prime 3? So this is just our inverse formula. So g prime 3 is like 1 over f prime. So g of 3 is f inverse. So then you would say, okay, that means that it's 6. So it would be 1 over f prime of 6, which would give you 1 over negative 2. Because g of 3 would be like when f is 3, so it's 6. So it would be 1 over f prime of 6, which is negative 2. Okay, 17, we have a function with h. If the tangent line to the graph of h at x equals negative 2 is parallel, which means the slopes are the same to the line that contains these points, what is the value of k? So first things first, I would find the slope of these 2 points. So 15 minus 3 is 12. Over 3, which is 4. So it says if the tangent line to the graph of h at x equals negative 2, so now I know my slope, I know h, so I want to find h of negative 2. So negative 2 cubed would give you negative 8 plus k times negative 2 squared, which is 4. And then I know that h prime of x has to equal 4. So I could use that idea. I know that my x is negative 2. So that would be like 3 times 2 squared, which is 4, plus 2k times negative 2. So then we get that all of that has to equal 4. So 3 times 4 is 12. Subtract 12 from 4, you get negative 8. Then we have negative 4k equals negative 8. Divide both sides by negative 4. And we get k equals 2. Is everybody okay with that one? Oh, another k one. So it says in the xy plane, the line x plus y equals k, where k is a constant, is tangent to the graph of the original. So this represents our tangent line, aka the slope of that graph. What is the value of k? So again, if you kind of rearrange these terms, you'd have y equals negative x plus k. If you take your derivative of the other graph, you have y prime equals 2x plus 3. If these represent the same thing, then all you have to do is set them equal to each other and solve for k. Let's give you answer choice A. Yes. Since this represents the tangent line to the graph of this, and this represents the derivative, then this is going to represent the equation of the tangent line. This is the slope of the tangent line. So then if you pick like the 0.00, you could plug that in and that would set them equal. So you could pick like any point you wanted and they're representative of the same thing. You're welcome. Okay, this is a rate of change. I can see it just reading that first sentence. If the base B of a triangle is increasing at a rate of 3 inches per minute and its height is decreasing, so this is positive, this is negative, that's my dB dt, this is my dH dt. Which of the following must be true about the area of the triangle? Well, if the base is increasing and the height is decreasing and they're increasing and decreasing at the same rate, the area would not always be increasing or always decreasing because these are opposing in signs. So then we're down to A also isn't going to remain a constant because what if your base is 5 and your height is 6? Or what if your height is 6 and your base is 3? So it's all going to depend on the sign of the base or the height. So if base is increasing and height is decreasing, then the area will be decreasing when the base is taller than the height, which is letter D. Okay, and then 24 is just a derivative again. So you have if f prime of x is equal to the following. So again, you start on the outside and you work your way in. So the derivative of sine is cosine. Times the derivative of the natural log. Well, the derivative of natural log is 1 over u times u prime. Now, here's where I think we goof up. We all kind of stopped here. But this is the outside, then inside. But this is also going to have to kind of take into play. So my 2 and my 2 cancel each other. So you have cosine ln 2x over x, which is answer choice B. I think we forgot, and again, I didn't look at the answers. I'm going to think we had a lot of C's because we forgot to multiply by that derivative of the 2x, giving me that extra 2 right here. I'm going to think we had a lot of C's because we lost this 2 here. Okay, let's go back and look at 13 where I can actually write everything down. So again, this is a linear approximation. You're trying to approximate 0.5. So what you want to do, this is like our Newton's method type thing. You want to first find your derivative. So I have 1/2 e to the x plus 3 to the negative 1/2 e to the x, because the derivative of e to the x is e to the x. Derivative of 3 is 0. And then linear approximation says that it's f of b plus f prime a of x minus a. So in this case, my x is 0.5. So I'm trying to find an A value that is going to be logical for this problem or easy to plug in. And that's where I was getting, like, having trouble typing it all in. So if I look at f of x and I want to approximate 0.5, then I need to pick a point near 0.5 to plug in. And the easiest point when you have an exponential is always a 0. So I'm going to use f of 0 and f prime of 0 to help me. So f of 0 is the square root of e to the 0 plus 3. Well, e to the 0 is 1. 1 plus 3 is 4. Square root of 4 is 2. So e to the 0 is 1. E to the 0 is 1. So 1 plus 3 is 4 again. Square root of 4 is 2. 2 times 2 is 4. So that makes this 1/4. So that means this is my slope. So that goes in here. I picked 0 for my A. Here's my f prime of A. So B is the answer I got here. So that's 2. So I get 2 plus 1/4 times 1/2, because 1/2 minus 0 is 1/2. 1/2 times 1/4 is 1/8. So I get 2 plus 1/8. So if I go back to that packet, I'm in the wrong packet, sorry. It can't be A, can't be B, because my answer is 2. So then I have to determine, is it C or D? Well, D would be 2 1/4. So I just said this was 2 plus 1/8, so that makes my answer choice C. So again, is everybody okay with that now? Like I said, I just couldn't type. I couldn't type that. That was too much. I'm starting to lose myself in the work. Any other questions from that packet you want to see the work for? Written down, written out. Okay, then today we are moving into our theorems. So I kind of like wrote out an outline for like our week. So to get through everything before next week. So like today we're doing EVT, IVT, MVT, and justifying. Tomorrow's PVA, that's position, velocity, acceleration, and FTC. Wednesday will be slopes, diffie-Qs, and integrals. And Thursdays will be area and volume, as well as Riemann sums, trapezoids, etc. Friday is going to be the cluster of all clusters. And then Monday, do you have an AP exam Monday in the morning, or will I have you Monday morning? That's what I thought as well. So I will have you Monday. That'll be our last day before your exam. Okay, and then I know there were, and I guess I missed the 24 and 25. So the answers in this packet we just did 24, in case you wanted to know, was, or we did 24, rather, we didn't do, I didn't give you 25 and 26. 25 was D, and 26 was B. Okay, and I think 25, here is your work for 25 and 26. I think I skipped them because of how they were in my packet, so you can look through. I think they're both not tricky, but you can see they're both difficulty level 4s. handouts. This is just a summary or a review. It is all your important theorems. It is all the important work. So again, this first paper I'm giving you, there's no problems or work for it. This is kind of like one of those things to know or what to know with definitions and examples. It goes through all of those key ideas and points. So today we're going to work on writing justifications as well as your theorems. So, like I said, the best way to get good is to continue to practice and try. So we're going to start with writing justifications today. So go ahead, take a minute and read through the example. This would be a calculator question based on the fact that this function is a cosine. So you can use your calculator, plug in your function. Okay, so I plug it in. It says at the beginning of the workday there are 500 tons. That tells me that's my initial condition. I'm going from 0 to 8 with a constant rate of 100 tons per hour. And the unprocessed is modeled by this. So processed, unprocessed. Find G prime of 5. Okay, so that's easy. Here's my Y or my G. So I'm just going to leave that. I'm going to go to math. I'm going to go down to 8. I'm going to type in X. Bars, Y bars function, Y1. Type in 5. So boom, just earned myself a point on the AP exam. The second part though says using correct units, interpret your answer. All right, so G of X represents the gravel that is unprocessed or arriving. That's like my rate in. It's decreasing. So I'm going to say the rate at which gravel arrives is, I'm going to account for the negative by saying decreasing by whatever my number is, so 24.5875. What does that represent? That represents tons per hour at T equals 5 hours. Part B, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this day. So that's the opposite direction now. That's 0 to 8 of G of T dt. So now we're math 9, 0 to 8, bars, y bars, function, y1, dx. So that's 825.551. And this, if that's tons per hour, this is tons. Is the amount of unprocessed gravel at the plant increasing or decreasing? At time t equals 5. So that is asking me for essentially G of 5. Because again, remember, we're trying to find out if it's increasing or decreasing. So if I look at that function at 5, so I'm just going to go to my table. If you're an ask, you could just type in 5. I get 98.141. The initial amount, or the amount that's being processed, is 100. So that's less than 100. So it says, is the amount of unprocessed gravel at the plant increasing or decreasing? Since the amount is less than 100, it's decreasing. So the amount of unprocessed is less than the rate that is being processed, therefore it is decreasing. Yeah. Yes, but you would have to compare it still to the amount that's being processed. So like that's not like you could use that. You would just have to say that because it's negative and the derivative of the processed was 0, then you could say it also. But yeah, you would still have to go back because it's not necessarily just asking you about the unprocessed. It's asking you about like the two being compared. Does that make sense? And then the last part, this is hopefully for you, the connections being made, it's going to be your FTC or your net change, because it says what is the max amount. So now we're talking about amount, so that's a new function. So we're making a new function. What is the max amount? So I'm going to need to know the derivative of my new function. What is the max amount of unprocessed gravel? So that's my G at the plant during the hours of operation on this day. So it starts with 500. It's changing at G of T dt minus the processed, which is 100. So the amount of unprocessed versus processed given initial. If I want to know the max, I want to know when this is equal to 0. So that's the derivative. Derivative of 500 is 0. The derivative of the integral is a function. And the derivative of the integral is the function. So I want to know when g of t is equal to essentially 100. So I'd go to my vars. I would type in 100 for y2. I would change my window so that my x's are going to be between 0 and 10 is fine. But again, we know the workday is 0 to 8. And my y's, well, I'm going to make my y min 95 and my y max 105 because all I care about is where they intersect at 100. There's my g. So they intersect. Again, this is going to be beyond my range because I went 0 to 10. That's 9. So there's only one point of intersection. And they intersect when x, or t, is 4.9234 hours. So FTC, this is an EVT because I got to check my initial condition, which is 0. I got to check my point of intersect, and I got to check the end of the day. So again, I'd make my life easy. In here, I would not erase my y1. I would go in and erase my y2 and change it to my a function. Or at least use this idea down here so you could change it, use it. You could go to this screen here. We already know we're going to use this value. So I could hit enter and bring down my curve for what I already have. Subtract the curve for what I don't have. So since I already have 8 plugged in, I'm just going to start with the n. And don't forget your initial condition of 500. So there's my g of t, there's my 100, and here's my initial condition. So this is giving me at time 8. So at time 8, it's 525.551. Go back up, arrow, hit enter, and change all of those 8s to 0, which would be easy because 0 to 0 is 0, 0 to 0 is 0. So your initial should be 500. That's easy enough. So now we got to change them to that point of intersect, 4.9234. And you get 635.376. So the max amount of unprocessed gravel at that plant during the day is 635.376 tons. So again, that would be in terms of tons. Okay, so I want to see what we know, how we know, etc. I have a free response for you. So you are going to take 15 minutes and try this on your own. I'm going to collect it and take it back from you at the end. It is a calculator question. I want to see what we've accomplished. This is everything we've just kind of talked about. So all you need on your desk is a calculator and a pencil. When you're done in 15 minutes, I'll give you your homework to review for tonight. Okay, so this will be till 55. 55. C prime. Okay, you have 1 minute remaining. Okay, please put your pencils down. Make sure your name is at the top. Okay, for homework tonight, in that packet I gave you that we did the front problem on, I want you to do 4, 6, and then the last 4 multiple choice. That's it. So free response 4, free response 6, and then the IVT, MVT multiple choice on the last 2 pages. So you're skipping the multiple choice in the middle, you're going all the way to the end, and you're doing the last 4 multiple choice. So 4, 6, and the last 4 multiple choice. Tomorrow, hopefully I'll have all of the test exams made up. I'm waiting for a kiddo to take one of them, and so I have all your stuff graded. I'll give all of that back to you, and so I've just been waiting to get my makeups done. I'll give these back tomorrow. Okay. I'll give you lots and lots of papers back tomorrow.
How many points is that? 46.
No, like 18.
That's 18.
They're worth 9 points, so I usually double it when I do them as classwork.